Hello students, in previous class we already discussed about what is optical instrument and we already discussed how a simple microscope works and what are the maximum magnification and minimum magnification we can able to get from a simple microscope. Okay, next we are going to study about if for an object, we already know if here is an object of height h which makes an angle theta naught with I when the object is placed at least distance of distinct vision. This is the maximum angle of view for a naked eye that the object of height h can create, and from this we can get the theta naught value or the angular magnification for the least distance of distinct vision. Position of the object will be this much, h by d. A naked eye can get this much amount of magnification of the object of height h, because if we move the object towards the eye further, it will come close to the eye more than that of the least distance of distinct vision, so that the image is not able to form on the retina, so that we can able to see the image of the object. So if we can increase the magnification for a naked eye beyond this is the maximum magnification can be obtained for a naked eye of an object of height h which is placed at the position of least distance of distinct vision, so that if a object is not able to visible at least distance of distinct vision, then we have to use another instrument which is known as a simple microscope, which can further increase the magnification by theta. We will obtain for the normal adjustment of the simple microscope is how much? D by f. We already derived this one in the previous class, and the maximum magnification can be obtained by a simple microscope when the image is formed at the least distance of distinct vision, only 1 plus d by f. This is the maximum magnification obtained by a simple microscope, or simply you can write this m and this is m max, this is m minimum. This is for normal adjustment when image is at infinite. This is at least distance of distinct vision, when image is formed at least distance of distinct vision. So d by f is the minimum magnification obtained by a simple microscope, and 1 plus d by f is obtained the maximum magnification when image is formed at least distance of distinct vision. Clear? But if an object is still not visible by using a simple microscope which can produce this much amount of magnification, so there is a chance to increase the magnification by decrease the focal length. But we already studied that a very less focal length is not possible for a simple microscope, so we can't decrease the focal length very less. That's why if a object is not visible by this much amount of magnification of a simple microscope, to see a distinct view of the image of that object, we have to use a further improved microscope, that is known as compound microscope. Clear? So when an object is not visible by utilizing a simple microscope, we have to use an improved microscope, that is known as a compound microscope. Clear? So today we are going to discuss about compound microscope. Okay, so what is a compound microscope? So compound microscope is basically made up of two convex lenses. One of them have a small aperture and small radius of curvature, and other one have large aperture and large radius of curvature. Okay, so it is made up of two convex lenses. One have small radius of curvature and small aperture, and another one have large aperture and large radius of curvature. The small one face the object, it is known as objective, and the large one is facing towards the eye, it is known as eyepiece. Okay, both these lenses are arranged with a pipe, and the distance between these two lenses can be changed by using a perfect arrangement of screws. Clear? So for this I am drawing the simple ray diagram for a compound microscope. Let these two lenses are placed on a same principal axis. Okay, so it's have a focal length. Let this is the f naught, focal length of the objective. This is 2f0, this is also 2f0, and here it have a larger focal length. Let this is fe, writing here like this, it will be FE, and somewhere here it will be 2FE, and same here as this is FE, and somewhere along it will be 2FE. Clear? This is known as eyepiece, this is known as objective. Clear? So we have to place the object which image we want to observe just beyond the focal length of the objective. Let this is the object AB, which is placed just beyond the focal length of what? Objective. Okay. So as we know, if the object is placed beyond f0 and within 2f0, its image will be produced beyond 2f0 and plus infinite, which is inverted in nature, magnified and real. So its image will be obtained by drawing the perfect ray diagrams like this. Okay, let here be the image which is inverted in nature and magnified, A dash, B dash. Clear? Okay, so this will be the image of the object AB, which is magnified in nature and inverted. Now this image of the object AB will act as an object for the eyepiece. So if this is the eyepiece, let me make a little bit larger like this. So now the ray will goes like this. And they will somewhere here the final magnified image. Let this is the A double dash, B double dash. Here is the observer eye. Clear? Okay, so when an object is placed just beyond the focal length of the objective, its real, inverted and magnified image is formed on the other side of the objective lens, which is lies beyond the center of curvature of the objective and plus infinite. So the image, first image of this objective will be A dash B dash, which is magnified in nature, inverted in nature and real. But this A dash B dash magnified image of the object AB will act as an object for the eyepiece. So for the eyepiece, A dash B dash will act as a virtual object. So this will be a object which is placed within the focal length of the eyepiece, so that its virtual, erect and magnified image will be formed along the same side of the eyepiece lens, which is A double dash B double dash, as the A dash B dash image, which is act as an object for the eyepiece, lies within its focal length and fold. So its image will be virtual and erect in nature. According to this, if this is A dash B dash, which is actually inverted in comparison to the real object, but as this is act as an object for the eyepiece, so its image will be erect in comparison to this one. So as this is B dash A dash, so its erect image will be B double dash A double dash, which is lies behind it, virtual in nature and magnified. Clear? So the final image of the AB will be A double dash B double dash, which is highly magnified in comparison to the object, and it is inverted in comparison to the real object. Clear? So for the first magnification, we can write here as, if this is H and this distance is somewhat how lies between F0 and F, so this will be taken as what? This is known as U0, the image, this object distance for objective, and here is the image for the objective, so this complete distance is known as V0. Now this image A dash B dash will act as an object for eyepiece, so this much distance will be taken as what? UE, and the final image for the eyepiece will be this one, A double dash B double dash. So this is taken as VE, the image distance for the eyepiece. Clear? So if the height of the object is taken as h0, or this is h. So initially when there is no lens present, we know for a naked eye what is the maximum magnification or the maximum viewing angle, theta not equal to h by d. You already know about it. If the height of object is h, which is placed at the least distance of distinct vision, this will be the maximum angle of view obtained by a naked eye. Now if this is not visible for the eye, we have to use the compound microscope. So what will be the value of magnification for the compound microscope? This is the final image of the object. So this will be the angle, let it be theta, which is mixed with the eye. So this will be the viewing angle of the image, final image with respect to the eye. So theta can be written as how much? If this is h dash, or we can take this theta as the final image height will be h double dash. So we can write theta equal to how much? H dash by UE or h double dash by VE. We can write the same viewing angle theta equal to how much? H dash by UE or h double dash by VE. So I am replacing this with h dash by UE. So I can write theta equal to how much? H dash by UE. This is the magnification. Sorry, this is the angle of view made by the eyepiece with eye. So what will be the value of magnification? The magnification will be how much? Theta divided by theta naught. So from this we will get what is theta? Theta equal to h dash by UE divided by theta naught is how much? H by d. So this implies we can have h dash by h into d by UE will be the required magnification by the compound microscope. But here what is h dash by h? UE is the object distance for the eyepiece, D is the least distance of distinct vision. But what is h dash by h? So as we here know, h dash is the image height and h is the object height for the objective lens. So we can write here h dash image height with respect to objective divided by h object height with respect to objective can be written as how much? By the lateral magnification it will be V naught by U naught. H dash by h equal to how much? The image distance V naught by the object distance U naught. So this implies we can write the magnification by the compound microscope will be how much? V naught by U naught into D by UE. This will be the required magnification for a compound microscope. What is V naught? The image distance for the objective. What is U naught? The object distance for the objective. What is D? Least distance of distinct vision. What is UE? The object distance for the eyepiece. Clear? So this will be the in general magnification can be obtained by a compound microscope. Okay. So what is the value of maximum magnification and minimum magnification we can obtain by using a compound microscope. So for the minimum magnification or in normal adjustment. So up to this clear. So for the normal adjustment we know for normal adjustment or if we want to see the image by relaxed position of the eye, so we have to adjust this objective and eyepiece in such a way that the image which is found by the objective lie on the focal plane of the eyepiece. Here it is somewhere lie within the focal length and pole, within the focus and pole. But for the normal adjustment we have to adjust this distance between the objective and eyepiece in such a way that the image A dash B dash which is found by the objective lie on the focus of the eyepiece. So for normal adjustment condition is what? The image A dash B dash must lie on the focus of the eyepiece so that its image will be found at infinite, so the rays can easily reach at eye. So for the condition for normal adjustment, the image A dash B dash must lie on FE. This implies UE will become how much? FE. Because if the image A dash B dash will lie on the focus of the eyepiece, then the object distance UE will become how much? FE, the focal length of the eyepiece. So this implies we will get the magnification which will be minimum in normal adjustment case will be how much? In place of UE I can write FE, so it will be V naught by U naught into D by FE. So this will be the minimum magnification obtained by a compound microscope in case of normal adjustment. What is normal adjustment? Image is formed at infinite and eye in relaxed position. Clear? So when the image is formed at infinite, the rays will become parallel, so they can easily reach to the retina of the eye, so the eye remain in relaxed position, and this is the value of minimum magnification obtained by a compound microscope, where FE is the focal length of the eyepiece, V naught is the image distance of with respect to objective, and U naught is the object distance with respect to objective, and D is the least distance of distinct vision of the observer, or in general it is taken as how much? 25 centimeter. Clear? So this is the minimum magnification obtained by an compound microscope. So what will be the value of maximum magnification we can obtain by a compound microscope? So as we already know, this is the magnification formula for any general position of the image, where UE is the object distance for the eyepiece. So for the maximum magnification, when we obtain, if we adjust this eyepiece in such a way that the image formed by the eyepiece of this image A dash B dash will lie on the least distance of distinct vision, then we will get the maximum magnification obtained by the compound microscope. So when the VE will be equal to D, that means the image distance with respect to object eyepiece will become equal to the least distance of distinct vision. That means the final image by the eyepiece will be formed at the least distance of distinct vision. Then we will get the maximum value of the magnification obtained by this compound microscope. So for maximum magnification obtained by a compound microscope, we have to take what? The image distance of eyepiece is equal to how much? The least distance of distinct vision. So for least distance of distinct vision, for maximum magnification by compound microscope, image should be formed at least distance of distinct vision. So this implies VE must be equal to D. So here we can write VE equal to how much? Minus D, because it is measured opposite to the direction of incident ray. FE equal to plus FE, positive, because focal length of a convex lens is positive. What is UE? Is negative, because it is also along the opposite direction of the objective, or sorry, eyepiece, to the opposite to the direction of what? Incident ray. So by replacing the value, we can find out the position of the object, so that the image will form at where? Minus D. So we can write it as the formula for UE will be how much? VE into FE divided by F minus VE, FE minus VE. So this implies we will get how much? Minus UE equal to VE is negative, minus D into FE divided by FE is positive, minus VE equal to minus plus D. Clear? Because V equal to how much? Minus D. So FE minus VE, which is equal to FE minus of minus D equal to plus D. Here FE is positive, V is minus D, so minus D into FE by FE plus D, which will minus UE, because UE also negative. So this implies you will get UE equal to how much? D into FE by FE plus D. Clear? This is the position where the image A dash B dash should be formed so that we can get the maximum magnification such that the final image A double dash B double dash will be formed at the least distance of distinct vision. So for this value of the object distance for the eyepiece, what will be the maximum value of the magnification of the compound microscope? We can find out. The maximum magnification of the compound microscope will be how much? We know the general formula for magnification of a compound microscope, M equal to how much? V naught by U naught into D by UE. So this implies here we can add the maximum value of the magnification will be equal to V naught by U naught into D divided by, in place of UE I can write this much, so it will be how much? D into FE plus D. So this will be how much? D will get cancelled. V naught by U naught into 1 plus D by FE. So this will be the maximum value of magnification can be obtained by a compound microscope when the final image will be formed at where? The least distance of distinct vision, where V naught U naught will be the image distance and object distance with respect to objective. FE is the focal length of the eyepiece. Clear? So this will be the maximum magnification can be obtained by a compound microscope when the final image is formed at least distance of distinct vision and the eyes in this position are in stress, because here the eye have to stress the most so that the final image will be obtained at where? The least distance of distinct vision. So this is the value of maximum magnification by a compound microscope, and we already get what is the minimum magnification, that is V naught by U naught into D by FE. This is the minimum magnification by a compound microscope where image is formed where? Infinite, and the eyes are in relaxed position. Clear? So this is how image formed by a compound microscope and how we can find out the magnification obtained by a compound microscope, and in general this is the magnification formula. Clear? Okay. So for a compound microscope, the distance between the objective and eyepiece is known as the length of the tube, which is denoted by L. So length of the tube will be how much? V naught plus UE. This is the length of the tube for a compound microscope, because V naught is how much? The image distance with respect to objective. What is UE? The object distance with respect to eyepiece. So the distance between objective and eyepiece is known as the tube length of the compound microscope. So for a given compound microscope, the tube length L is denoted by how much? V naught plus UE. For normal adjustment, what is the value of L? L equal to V naught plus FE, because for normal adjustment, this is for normal adjustment. When UE equal to FE. So L is what? L is known as tube length. Here L is known as tube length of the given compound microscope. So for normal adjustment, the tube length equal to V naught plus FE, because FE equal to UE for normal adjustment. Similarly, for least distance of distinct vision, what is the value of tube length? The tube length L equal to how much? V naught plus, in place of UE, what is the value of UE for least distance of distinct vision? Is D into FE divided by D plus FE. This will be the value of UE in case of least distance of distinct vision. So when the image is formed at the least distance of distinct vision, the value of or the tube length will be how much? V naught plus D into FE divided by D plus FE. This will be the value of tube length. Okay, clear? So the maximum magnification can be obtained by compound microscope is 1 plus D by FE whole into V naught by U naught, and the minimum magnification will be V naught by U naught into D by FE. Clear? So next, for a compound microscope, the tube length is very large in comparison to the object distance or objective length or the eyepiece focal length. Clear? So for objective we can write 1 by V naught minus 1 by U naught equal to 1 by F naught. This is the length formula for the objective. For V naught is the image distance, U naught is the object distance, F naught is the focal length. So multiplying V naught on both sides, we can write V naught by V naught minus V naught by U naught will be equal to V naught by F naught. Clear? this will be how much? 1. So this implies 1 minus V naught by U naught will be equal to how much? V naught by F naught. Okay, so this implies you can write 1 minus V naught by F naught will be equal to how much? V naught by U naught. Clear? Remember this relation where V naught by U naught equal to 1 minus V naught by F naught. We know the magnification formula for compound microscope. Minimum magnification will be V naught by U naught into D by Fe, and maximum magnification will be V naught by U naught into 1 plus D by Fe. Clear? Now V naught by U naught will be how much? 1 minus V naught by F naught. Clear? But the value of V naught with respect to F naught is very large. That means this term will be very greater than in comparison to 1. V naught is very large, or V naught is nearly equal to the length of the tube. Clear? The V naught is nearly equal to length of the tube because the focal length of the eyepiece is very negligible. So if V naught is nearly equal to length of the tube, so V naught is very large in comparison to F naught. So V naught by F naught term will be very large in comparison to 1. So this can 1 minus very large number will be minus V naught by F naught. We can write this much as minus V naught by F naught because this term is very large in comparison to 1, which is equal to V naught by U naught. So from this we can write this implies V naught by U naught, as V naught is nearly equal to what? Length of the tube. So minus L by F naught can be written as V naught by U naught. Clear? So what is L? L is the length of the tube, F naught focal length of the objective. So V naught by U naught, in place of V naught by U naught we can write L by F naught. L is length of the tube. So the magnification formula in terms of length of the tube will be how much? The magnification minimum will be minus L divided by F naught into D by Fe. This is the minimum value of the magnification by a compound microscope in terms of length of the tube. And for maximum magnification or for least distance of distinct vision, it will be minus L by F naught into 1 plus D by Fe. This is for least distance of distinct vision or maximum value of the magnification obtained by compound microscope. This is the minimum, or for normal case. What is L? L is the length of the tube, F is the focal length of the objective, D equal to the least distance of distinct vision, E equal to focal length of eyepiece. So you have to remember this formula. This is formula in terms of object and image distance. Okay, so these 4 formulas are important and you have to remember this relation also. Clear? And in general, what is L? L is tube length, which is how much? V naught plus UE. Clear? So this is all about what? Compound microscope. So now let's do a numerical for a given compound microscope. Having objective of focal length, that is F naught 1 centimeter, and an eyepiece of focal length, that is Fe 2.5 centimeter. Find the magnification for an object in normal adjustment. Okay, so for a given compound microscope having objective of focal length F naught is 1 centimeter and an eyepiece of focal length Fe equal to 2.5 centimeter, find the magnification of an object in normal adjustment which is placed at 1.2 centimeter from objective, and also find the tube length of the microscope. Okay, so this is a given question. So for a given compound microscope, we have the focal length of the objective, focal length of the eyepiece, and image distance with respect to objective. Clear? And the condition is we have to find out the magnification for normal adjustment. So according to the question, we have the data f0, which is equal to how much? 1 centimeter. Fe is given as 2.5 centimeter. Okay, condition is for normal adjustment. Okay, and we have what? U0, in object distance to the objective, that is 1.2 centimeter. So according to sign convention, focal length for both the lenses will be positive because both are convex in nature. And what is the value of U0? As U0 is opposite to the direction of incident ray, it will be negative. Clear? And for normal adjustment, what is the condition for normal adjustment? Condition for the normal adjustment is the image distance for the eyepiece will be equal to the focal length of the eyepiece. That means the image formed by the objective will lie on what? The focus of the eyepiece, so that the final image will be formed at infinite. And for this we have the magnification, which is minimum, equal to how much? V0 by U0 into D by Fe. Clear? So this is the condition for normal adjustment. So from this we can get what is the value of V0. We know 1 by V0 minus 1 by U0 equal to 1 by F0. So this implies we will get 1 by V0 minus of 1 by minus 1 by 2 to 1 by 1 divided by 1.2, which is equal to 1 divided by F0 is how much? 1. Clear? So by solving this we will get, this implies 1 by V0 equal to minus 1 by 1.2. So this implies V0 will be equal to how much? By solving we will get V0 equal to, sorry, it will be 1 minus 1 by 1.2. So V0, 1 by V0 will be equal to 1.2 minus 1 divided by 1.2. So this implies 1 by V0 will be equal to 0.2 divided by 1.2. So this implies 1 by V0 equal to how much? It will be 1 by 6. So this implies V0 equal to 6 centimeter. Clear? So we will obtain the value of image position with respect to objective is how much? 6 centimeter. Clear? So now we can find out the magnification. So the magnification will be how much? We have the value of V0 and we know the value of U0. So the magnification will be how much? V0 by U0 into D by Fe. So this implies the magnification will be V0 6 divided by U0 1.2 into D 25 divided by Fe 2.5. So this implies it will be 10, it will be 5. So magnification is 50. Clear? So the magnification in normal adjustment of the object is 50. Clear? And the second question is what? Find the tube length of the microscope. So as the condition is normal adjustment, that means the image is formed at focal length of the eyepiece. So the object distance for the eyepiece will be UE, and we know the tube length L equal to how much? V0 plus UE in general. So here we can write the tube length L equal to V0 is how much? 6 plus UE. UE is what? UE is equal to the focal length of the eyepiece, that will be how much? 2.5. So 2.5. So the tube length will be 8.5 centimeter. Clear? So for the given question, this is the magnification in normal adjustment, which is 50, and this is the length of the tube of the microscope, which is equal to 8.5 centimeter. Clear? So this is how you can solve different numericals based upon the application of compound microscope and also as well as the simple microscope. Okay, this is all about compound microscope. In next class we will study about telescope. Clear? Thank you.